so sampling and bias. So this section, this last chapter we're going through, is all about statistics. So we're just working with data and how we can make it tell us something, okay? So first we're talking about sampling and bias. When we wish to make an investigation, meaning we want to gather some data and figure out what it tells us, there's 4 different ways we can do this. First, you can look at published data. So that's already in a source. Something that's already in a source, like in a newspaper or a book. So something that's already been done. So they already did the legwork work and collected all the numbers for you, then you just do the work and stuff. Observational studies, watching naturally occurring events and recording the results. You can go out and watch how many birds come down and fly down and pick at the road over there. Okay, something that you can watch and then you can write down and record the results. An experiment is usually if you're doing something in science where you're going to conduct an experiment to figure out what happens. Survey is what we usually use or think about when we're working with statistics. Is a survey when you're going to go out and ask a bunch of people a bunch of questions and figure out what their answers are. So a sample. A sample is a portion of a larger group, and that larger group is called the population. And a census is all the units of the population are represented. So a sample is a little part of the population. The population is everything. Can I get a question?
So a sample is just like a smaller part of the whole census.
Exactly.
That's what it is.
Yep.
Instead of, then the census would be with all of those people in it.
I like a more specific example of that.
Okay, well, like census, like if we're going to do the U.S. census.
It's like I am a person in a classroom, and then there's a whole school. There's like a population of the school, and then we're like a sample of this class is a sample of the school.
Yeah, everyone is picking this class, or the math class.
Yeah, that would be a good example. Sure. Sorry about that. Alright, so yeah, sample is just a smaller part of the larger population. So yeah, like Jared said, the whole population of the school, and then we could be a sample because we're just picking just part of it. Like a census, like the U.S. Census is every 10 years, like you said. It's when everybody in the U.S. has to answer a survey. So that's obviously not something that you want to do very often, just because it takes so long and you have to make sure you get every single person. So usually they just do it with a sample, so they don't have to contact everybody. And then a couple of examples here. So population, the whole thing is all the light bulbs manufactured on the production line. A sample would be just 24 light bulbs selected from that production line. So sample is just a little bit of the whole thing. Any questions on that yet? Alright, so random sample. Random sample is representative of the whole population. And the sample is chosen without any preference. So we got 3 different types. We got a simple random, stratified random, and systematic random sample. A simple random sample is a sample that is as likely to be chosen as any other. So it's all just random. You don't have anything that has a better chance of being picked. Like their example, there are 26 students in the class are assigned a different number from 1 to 26, and then 3 of those 26 numbers are picked at random. So basically, you just put all the names in a hat and pick out 5 or something like that. That would be a simple random sample. Stratified random sample, the next one. The population is divided into similar, non-overlapping groups. So you divide it into groups first, and then you pick from each group. So let's say if I had the seniors, juniors, sophomores, and freshmen, and I've separated all their names into 4 different hats. So I have 1 hat for the freshmen, 1 hat for the sophomores, 1 hat for the juniors, and 1 hat for the seniors. And then I picked names out of each of those hats. That would be a stratified random sample because I'm grouping them into pieces first, then I'm pulling out of each piece. Does that make sense? Not your heads? Okay. And then the last one, systematic random sample, has to do with time. So specified time or time interval. Like their example over there says every 2 minutes an item is pulled off the assembly line, or every 20th item is pulled off an assembly line. So it has to do with time or a certain amount after each interval. Alright, so example 1 says 10 lakes are selected randomly from a list of all public access lakes in Minnesota. Then 2 liters of water are drawn from 20 feet deep in each of those 10 lakes. Identify the sample and suggest a population from which it was selected. What are they given?
Given a stratified random sample.
Well, okay, we're not quite there yet, but yeah, do you think it's a stratified random sample?
I do.
And why?
Because they put the 20 different, or no, the 10 different lakes into different groups, and then they took a random amount, or a random 2 liters of water from 20 feet deep in each of them.
Okay.
And so they took just a random one from each group.
Do we have different groups though?
Yeah.
We don't have any different groups because they're just saying they're selecting from, okay, 10 lakes are selected from all the lakes in Minnesota. We're just picking 10. I'm just collecting water from 10.
Mississippi River.
Is that in Minnesota?
No.
That is.
Yes.
One of the
It goes
it's
there.
not that one.
Minneapolis.
Mississippi River goes through us, right in the middle. It doesn't, it's not in Minnesota.
What?
It's not in Minnesota.
You've lost.
Don't worry about it.
Well, they chose Minnesota because Minnesota is the land of 10,000 lakes.
Yeah, Minnesota has a bunch of lakes.
And they chose to use.
Well, yeah, you wouldn't want to go throughout Minnesota and draw water from every single lake because that would take you like forever. So they're just picking randomly picking 10 lakes out of all of them and drawing water out of each one. So let's say I would just say it's a simple random sample. It's not stratified because there are no groups. They're not proving it. And it's not systematic because it has nothing to do with time. Nothing to do with time, nothing to do with groups. So it's a simple random sample. Let's go back up here to A. It says identify the sample and suggest a population from which it was selected. So what are they picking? What's the little group? What are they comparing? 2 liters of water from?
Each of 10 lakes.
So that would be our sample. Our
From
sample
20
would
feet
be
down.
2 liters of water from 10 lakes.
Was it 20 feet deep, really matter?
And you can put it in there, but I wouldn't. Okay, and then the population, what's the larger group that we're picking the sample from?
Oh, all 10,000 lakes.
So all the lakes in Minnesota. Is Minnesota in?
And then,
Yeah. Just never doing those abbreviations. All right, any questions on this type of thing?
why does it say suggest a population? Because there's really no other choice for a population without one.
Well, it says public access lakes, so I guess you could say all the lakes or all the private lakes and the public lakes. I mean, yeah, it just depends on how you word it. So as long as you say something along the lines of all the lakes in Minnesota. I mean, our population is not going to be all the lakes in the U.S. because we're just looking at Minnesota.
Right.
Oh, okay, great.
You know what?
He's right, so yeah.
Oh, he's got
Okay.
Got it? Alright. Okay, so a biased sample is when one or more parts of the population are favored over the other, so they have a better chance of being picked. So it's a biased sample. Number 2 says identify each sample as biased or unbiased and explain your reasoning. So we're aiming every 100th or 1,000th volt is pulled from the touch line and measured for length. Is that going to be biased or unbiased?
unbiased.
Unbiased. Why?
Because it's not biased. They don't decide which one is 1,000.
It's
True.
not like, it's not like every, it's not like, I want this one, this one, this one, like, a certain number, just every 1,000.
Uh-huh. Okay, so let's go back. I think it's just easiest to say because it's what kind of sample?
Simple random.
Simple random?
No, systematic random.
Yeah, it's a systematic random sample. So that means it's unbiased. System, oops. That doesn't look right. I was T in there, didn't I?
Yes,
I can't spell the same like systematic. Wow, random.
Unbeast.
Okay, so systematic random sample meaning it's a timer. Okay, part B says every 10th customer in line for a certain rock band's concert tickets and asked about his or her favorite rock band.
Biased.
Why?
Because they're already in a specific rock band's concert, or they're already buying tickets for a specific rock band.
They're going to their favorites.
And so more than likely that's at least one of their favorites.
Yeah, bias because
Like picking one.
people in line will probably be probably hear the band giving the concert.
Because they don't want to look like, well, then why are you here?
Yeah.
So now you say King Ontario, like,
Yeah. and it's- No. It's a horrible.
All right, so we've got two different biased samples. Okay, so we've got a convenient sample and a voluntary response. So convenient sample includes numbers of a population that are easily accessed.
Like,
So example over here it says to spoil produce worker selects 10 apples from the top of the bin, and 10 apples are unlikely to represent the whole thing because
well, because they were picked at different times, but like going to, if you were wondering about living situations in a certain area, just going to the elderly people because they are easy to, I mean, you know that they're going to be there and they're easy to access.
yeah, that would be a convenient sample because it's just whatever's closest or whatever's easiest for you, but not necessarily representative of the whole population.
Right.
Yeah. Like with this one with the guy picking the apples. If he only picks the ones on the top, of course, those are probably going to be pretty good. The ones that are spoiled are usually down at the bottom. So if you wanted to be more unbiased, you probably would want to pick one from the top, one from the middle, one from the bottom, one from the side, one from every, all over rather than just the top. And then voluntary response is only those that want to participate. For example, over there it says the radio call-in show reports that 75% of its 40 callers voiced negative opinions about a local football team. Those 40 callers are unlikely to represent the entire local population. Voluntary callers are more likely to have strong opinions and are typically more negative than the entire population. Because usually the ones that volunteer information are the ones that are very, very opinionated and they have a strong view on things, so those are usually the ones that speak out.
Because think about how many people don't really care.
yeah.
That's it. All right, so example 3 says the travel account records from 4 of the 20 departments in a corporation are to be reviewed. The accountant states the first 4 departments to voluntarily submit their records will be reviewed. So what's our sample?
Departments.
Not quite. What's our
Four
sample?
departments.
For what?
Just departments.
Okay.
Account records.
There we go. Because I'm collecting their records. Yes.
Four department records.
So account, travel accounts, account records
It looks like English now.
from 4 departments.
Population would have been records from the other 16.
Right. So population, Will be records from all departments,
Can we just put S and P?
That's what I did.
I suppose.
Okay.
So population records from all the departments, or all plumbing, you can say all plumbing. So then we're supposed to classify it as convenience or voluntary response.
It'd be voluntary,
Yeah, because they give us that word right here.
the first voluntarily submit.
Alright, and then example 4 says, for an article in the school paper, Raphael needs to determine whether students in his school believe that an art center should be added to the school. He polls 15 of his friends who sing in the choir. 12 of them think that the school needs an art center, so Raphael reports that 80% of the students surveyed support the project. What's our sample?
15 people in the choir. Well, no, it's a very biased.
The choir. And you're right, they're his friends. So it is very biased. Okay, population. So what really should be represented?
But
Why?
The whole class or the whole,
school,
I'd say the whole school, because the students in the school.
Arts.
About the arts.
No.
So I would say all the students.
what about one from like every different class?
Well, he did,
No, like, what if we took one from the choir, one from like the science department, and one from the math, and so on and so forth?
that would be much a better
Would that, I mean, if it were just random people, it wouldn't be biased, would it?
If he grouped them first and then picked them out, that would be okay, because that would be that'd be this one, this is stratified, so it would be unbiased then. Okay, and C, state whether this is unbiased or biased. It's biased. Okay, it says if bias classified as convenience or voluntary.
Convenience.
It is. Why is it convenience?
Didn't give them a choice.
It's
Well-
voluntary.
Because if we know it's biased and we know it's not voluntary,
Okay, well, it's not voluntary because he didn't just give it out to all the people and say, if you want to tell me your opinion.
because there's friends.
Right, there's friends. So definitely if you're just gonna pick friends, yeah, it's convenience because those are just people that are nearby and they're easiest to ask. Yeah. Alright, questions, comments?
What is our homework?
What does that have to do with math? This is all about,
No,
oh, no, it does. We're all talking about is
I would look up
working data. Working with data, like all about statistics.
Problems.
I know because she's not.
So it'll be like a blood problem?
Oh, that's like not much.
Are you going to take